Welcome. Today we're going to take a look at our Algebra Tiles manipulatives. And as we're looking at this one, we are actually going to follow along with the worksheet packet that you have uploaded into Canvas itself. So it'll say things on the top like Activity 1.4, Activity 3.1, and so on. And as you take a look at that, what I want you to recognize is this obviously is coming from a much larger activity set, and we've selected just a few of the items so that you can get a sense of how this particular manipulative could help if you were teaching beginning algebra to a group of students. So to start with, let me show you the manipulatives that we would normally work with in class, and let me talk through a little bit about what they are. So we've got a large square, okay? It's blue on one side and it's red on the other. The blue side is positive, the red side is negative. Now, honestly, I wish all my manipulatives were the same color. That is, that all the sides were blue for positive and all the sides were red for negative. They're not. This is another cube that we have. It's again red for negative, and it's now green for positive. Not my favorite, but that's the way it works. And then we have these little bitty squares, and they're yellow for positive, and they are red for negative for the little bitty squares. So let me tell you what each of these represent. Well, actually, let me start with the little one. This piece right here represents the unit 1. Okay, so this is one little square, it's the number 1. And if you were to make this 1 long, right, it's the same width across, but you make it really long, but it's not exactly like 3 or 4 or whatever, it's an arbitrary length. This tile represents the number x. So this is 1 and this is x. This would be -1 and this would be -x. And then if you put these on the sides and you make a larger square out of them, right, x and x, you get clearly x squared. So this block is x squared. This block would be -x squared. So as you're taking a look at activity 1.4, it's asking you to draw pictures of these blocks. So when it says x squared, you're going to draw a large block, right, for x squared. You're welcome to use colors. That would be wonderful. I would love it if you used red for negative and then any other color you want for positive. That'd be great. If you don't have colors or you don't want to use colors, you just want to use pencil, what we do is we shade in for negative. And so if the box is empty, it's hollow looking, that's a positive x box or a positive x squared or a +1. And if it's shaded in, it's a negative. So shaded boxes are negative boxes. Another thing that students sometimes come into problems with on number 3 and number 4 on this particular page is remembering what binomial and trinomial mean. Binomial means it's two terms with addition or subtraction technically between them. So if you look at problem number 2, 3x squared plus 2x, that is an example of a binomial. And then a trinomial is 3 terms separated with addition or subtraction. We're using addition for these problems. So example number 1 is a trinomial. It has 3 terms, x squared, 4x, and 2, all separated with addition. So go ahead and complete the first worksheet, drawing your pictures and or giving an expression and then drawing the pictures for 3 and 4. And then come back with me for the next lesson. All right. So as you're taking a look at the next lesson, it's actually talking about, it says activity 3.1, about ways that you can take algebra language and express them with the algebra tiles. So what you see is it describes 3 times the number increased by 4. Well, a number is a general term for describing something we don't know the value of. So 3 times the number would be 3 of my x bars. Okay, so it would be 3 of them. And then it says increased by 4. So increased by 4 means you add 4 to it. So you would add 4 of my little number cubes to that diagram. So 1, 2, right, 3, and 4. So this would be the increased by 4 part, right? These 4 added to it. So you see an image. They draw you a picture of 4 of the long pieces. Those are the x's. I'm sorry, 3 of the long pieces, the x's, and then 4 of the little number cubes for the number 4. And the algebraic expression that that's modeling, of course, is 3x plus 4. You can do the same thing with decreased by. So on the other side, the second example that it gives you, it talks about 2 times the number, right? So 2 times the number looks like this. And then it says decreased by 3. Well, I don't know exactly what that looks like if I sort of break these apart because I don't know how big these are, right? So the way that we express decreased by 3 is that we use the red side of our number tiles. So we would have 3 of these little number cubes, and this would be the decreased by 3 part. So 2 times the number decreased by 3. And And what you'll see on your paper is they have shaded in cubes, the little bitty ones, to represent that these are 3 negatives. So the algebraic expression that this represents is 2x minus 3. So what you're having to do on examples 1 through 6 below on that worksheet is to create the imagery with the algebra tiles, shaded in or hollow, right? X's and number cubes, and then to write the corresponding algebraic expression below it. So just like we were describing below, for the two above, right? The last one I did was 2x minus 3. The first one I did was 3x plus 4. So you're going to fill in the different components of this particular worksheet in 2 forms, both the visual form and the algebraic form. Go ahead and push pause, complete lesson 3.1, and then come back and we're going to take a look at lesson 5.2. All right, I hope that at this point you have completed 2 lessons and you're on the 3rd lesson. It's titled Activity 5.2, 5.2, Evaluating Quadratic Expressions. So with this one now, we're actually using the x squared tiles as well that we talked about, these like this, right? This is your positive value, this is your negative value, and if you're drawing them on paper and you just want to use a pencil, you shade in for the negatives and you leave them hollow or unfilled in for the positives. And this lesson actually talks about what we do for evaluation. So it talks about creating the expression first, x squared plus 2x minus 1. So what you see on there is you see the x squared tile, you see the 2 x's, right? And then you have the negative 1. So this is the expression that they draw out for you, but with hollow and solid colored shapes. So these are hollow, right? The x squared and the 2x, and then this one is filled in the negative 1. And what they're wanting you to do is they're wanting you to let x equal to 2. So each of these will be replaced with 2 of these. So what you literally do is you take this piece and you replace it by drawing this piece, and you do it for both of my green long pieces, so you have 2 of these next to each other. Okay? You still have the negative 1, right? They still have the negative red cube, one of those red cubes, but you have 2 sets of 2 yellow cubes as well. And then you have to do 2 squared, right? Because what we actually have on this one is a side length of 2, so this is 2 times 2. So you have a square of size 2 by 2. So your x squared will actually be replaced with the imagery that looks like this. So this is 2 squared. Okay? So you've got 4, right, little yellow pieces replacing the x squared. You've got 2 and 2 replacing the 2 green lengths. And then you have a negative 1 at the end. And then what you do is you just take away pieces that are 0 pairs. So a red cube and a yellow cube combine to be a 0 pair because you have a negative and you have a positive, and those add to 0. Those of you who've taken number theory, we've seen 0 pairs before when we do when we do number theory, we've seen 0 pairs. So if you have had that class with me, you've seen this in a different imagery with circles or pluses and negative signs. Regardless, this pair gets removed. So now I still have 4 of the yellows, right, for the x squared term. But now I only have 3 from the 2 x's. One of them is still complete, and one of them is only 1 because I removed one of them to make up for the 0 pair that added to the negative, the red cube. So that's 4 plus 3, and I would have the number 7. All right? So what you're doing is you're doing just that. So if you're doing your problem number 1 is x is equal to 3, your x squared piece would be 3 times 3, or 9 individual hollow cubes. Your x piece would be 3, right, because x is equal to the number 3 in that one, 3 hollow cubes. And then you have a negative 3 already in there, the filled in 3 cubes. You would pair them up, right? Every positive pairs with a negative, and then they can be zeroed out. What you would be left with then is what your answer would be. And then checking to make sure that it is correct, you can actually evaluate the numbers themselves, just like you can do the removal of pieces. Okay, so go ahead and pause. Take a look at numbers 1 through 7. I wish again that I had the ability to give you these number cubes to actually play with it. If we were doing this in class, I would make you do it with the cubes because that's what you would have your kids doing if you were teaching this in the classroom, and I don't really have that ability here. You're welcome to cut out number cubes. That would be a possibility. You can Google for slides that allow you to color and cut those out to manipulate with them if that's helpful. But go ahead and pause, complete activity 5.2, and then come back for 5.3. All right, welcome back for activity 5.3. And activity 5.3, what we're going to be doing is we're going to be combining binomial and quadratic, specifically quadratic types of expressions. So some binomial, some trinomial. What you see for the example is it says x squared minus x. So this would be x squared, and this would be minus x. So this is the first image you see. They have a hollow x squared term and a filled in x term. And they're adding to that 2x squared. So this is 2x squared plus 3x on the other side. So these are the these are the 5 pieces that you see written or drawn on the other side. So 2x squared and 3x. And then what you're going to do is you're going to actually look again for 0 pairs. So what you'll notice is that you have a hollow or a red on the left-hand side, and you have a solid or a green on the right-hand side, and they're the same shape, right? These are the same objects. So they would create a 0 pair when they are combined. So the image you see them doing right beside that is taking and noticing that these create a 0 pair, hence they can be removed. And what you're left with is 3x squareds, right? So there's 3 of these. You're left with 2 of the x's, and this is your answer then, 3x squared plus 2x. So you're combining like terms is what you're really doing, but you're doing it with images instead of with numerical values. So as you're looking at problem number 1, you see the expression on the left. They're asking you to write it down. They're seeing an expression in number cube form on the right. They're asking you to write it down. And then visibly, what they want you to do is to go into that diagram and remove the things that can be removed that are in pairs, positive and a negative value of the same sized shape. And so if you remove those and you count up and you piece together what you're left with, that would be your solution for problem number 1. You do the same thing for 3 through 6, except that you don't have the images already written down. So again, if you were in class with me, ideally I would have you actually, like physically put down all the blocks, and you would be removing them, combining them, moving them around, shifting them to get your final answer. On number 7, they're actually asking you to write 2 different addition problems that would have this expression as a solution. So there's, infinitely many, basically, of different options that you could write down for number 7 that would all be correct. So go ahead and pause for me. Take a look at activity 5.3, and then come back and we will do our the other half of activity 5.3 as our next one. All right, welcome back. Activity 5.3, part 2, if you will, is the subtraction part. So we did the addition part in the last portion of this video. Now we're going to do the subtraction of our quadratic terms. So you'll see that there's 2 methods for doing subtraction. Both are equally valid, but a lot of times we've seen in this class where we look at 2 different methods or 3 different methods of doing the same thing because they all sort of resonate with different kids in our classroom. So the first way that we're going to actually look at this is usually the way that people don't care for as much. So bear with me. This is the way that we do it if we're thinking about subtraction as removal. So the expression that they give us on method 1 says 2x squared. So we've got 2x squareds plus 3x. Okay, so this is where we're starting. And it says it wants us to remove an x squared and a 2. Well, removing the x squared is easy enough, right? Because I have an x squared, I just take it away. But I can't remove 2 because I don't have 2 to remove. So what I do is I actually insert 0 pairs. So I need to be able to remove positive 2. So in order to not change the value of the expression, what I do, I can't pick them all up. Okay, I'm going to put these guys down. Remember, those are there. Is that I put in 2 positives and 2 negatives of the same thing. Can't pick them up. They're too little. Okay. So I have 2 positives and 2 negatives. These are a 0 pair. They add to 0. So if I put them into the expression, they don't change the value because they're balancing each other. But what they do when I have these on the board, as well as my original pieces on the board, okay, all the pieces, I had that one too, right? I had all these, is they allow me now to remove the x squared and to remove the 2. And what I'm left with then is x squared plus 3x and minus 2. Okay, so that's what it would look like if I insert 0 pairs so that I can remove the pieces that I don't want there. That's method 1. Method number 2 is usually the ones that people sort of gravitate towards. And I think that you do probably because the distributive property is very well ingrained in you at this point. So what they like to do is they want to be able to do on method 2 is to be able to distribute the negative through. In other words, I've got the same problem I had before. I have 2x squared and I have 3x, okay? And it still says minus x squared. And so what they do instead of actually removing an x squared is they say, okay, so minus x squared is the same as a negative x squared. So we're going to put this value now into our problems. Now I got one of these. And I've got a negative 2. So now I've got 2 of these, right? So this is what the expression looks like at the beginning. And then instead of inserting 0 pairs like I did last time, I remove 0 pairs. So these two create a 0 pair, so I remove them, and this is the expression I'm left with. The same x squared plus 3x minus 2 that I did before, but I did it by removing 0 pairs after I distributed the negative, instead of inserting 0 pairs and removing secondly. So those are 2 ways of doing subtraction. So go ahead and pause and take a look at examples 8 through 11, and then come back. We have one more piece to do in this lesson, and then we'll be completed with our Algebra Tiles section. Okay, for this one I'm going to try and flip the video around because I think it'll work better if you can see my my desk. So assuming I have a piece of paper. Oh, I'll use the back of this one. Okay, so just a second. Okay, I can't flip it around while it's in the video mode. I'll have to show it to you from my screen. Okay, so what I would like for you to do is I'd like for you to get a piece of paper, or at least visualize getting a piece of paper, where I have a grid marker, okay? So I've got a grid. It looks kind of like, you know, maybe an unequal, you know, XY axis or something like that. And what we're going to do on this problem is that we're going to take the algebra expressions that it gives us, in this case, x plus 3, and we're going to put it along the top and along the left-hand side of my grid. So x plus 3 would literally look like, you know, I'm going to use some tape. You got to get creative when you're trying to use limited resources, but I'm good at this. I can do this, I think. So we're going to do this piece at the top. We'll do this piece on the side for visual purposes. Okay, so I've got tape along my top and my side. So the first algebra expression it gave me was x plus 3. So I'm just going to put that along the top. Of course, my tape's not quite long enough. That'd be too easy. Okay, so this is what it looks like. I've got x plus 3 along the top, and I'm going to do the x plus 1 along the side. Okay, so this is my picture that I have so far. X plus 3 along the top, x plus 1 along the side. And what I want to do is I want to fill in a rectangle right here that's got this length and this height or width or whatever, you know, values you want to use, and it creates a rectangle nice and neatly right in this space. So clearly I don't want to just use a whole bunch of one thing. I want to minimize what I can do. And so the first thing to do is to notice that this blue square goes super nicely along the green ones. So again, let me do some creative sticking. So here's my x squared term right there, okay? And then I can use green pieces to make these 3 underneath the yellow, okay? All right, so that's what we have so far. I can use one more green piece down here because it'll be the same length as the blue. Has to be. Okay, so this is where I am. And then of course, my paper's getting a little heavy. And of course, to finish it up right down here, I need 3 of the yellows. Okay, so this is what we end up with, is this wonderful rectangle. Yes, I know that there's a little corner here missing, but the reality is that the rectangle that is my answer is the part that I added on the inside, right? Not including this part along the top and not including this part along the side. So the solution to the multiplication problem is actually x squared plus 4x plus 3. That's the solution to the first problem. So as you're piecing all that together, that's what you have. Now what it's wanting you to do as you take a look at numbers 8 and 9 and so forth is to do something in reverse. So on number 8, they actually give you the imagery that has, you know, these blue squares on it and these green long pieces on it. And they're trying to get you to figure out what you actually have as a multiplication problem there. So remember that when you're dealing with one of the squares, right, the side length is x. So if you see one of these squares in the diagram like you do on number 8, this side length is x and this side length is x automatically. And then when you see one of these green pieces, right, this side length is still x, but this side length up here, this tiny little piece at the top, has length 1. So if you saw this and this was your problem, you would say that this is x plus 1 times x, because I only have one side length over here. If it were filled in like, say, this, and pretend with me for a moment that my yellows are filled in on the corner here. I don't have the hand space to do that. But if it had it started out like this, you'd still have x plus 1 along the top, but now it'd be x plus 2 along the side. And so this particular problem would say x plus 1 times x plus 2, and then you would say that it equals x squared plus 3x plus, there were 2 yellow pieces missing, plus 2. That's what it would look like. So that's what you would be doing on numbers 8 and number 9. And then when you're looking at 10 through 13, again, you would be drawing a picture. If you were doing it in class, you'd be using my manipulatives by hand, and you'd actually be drawing out what that looks like. You'd have x plus 2, right, along the top. You'd have x plus 1 along the side. You'd fill in the rectangle that goes with it, and that would be your solution, is all the pieces of the rectangle inside of the multiplication. Okay, so when we're looking at this, this is x squared plus 4x. It's not x squared plus 6x. These don't count. These are part of this part at the top and this part on the side. Those are part of the question. They're not part of the solution. The solution is all the pieces that are making up the rectangle inside of this T-bar chart that you created. Okay? And the last one, number 14, is going to be tricky to do without the tiles. I'm going to be honest with you. But what we would be doing if we had it in class is you would be actually taking all those tiles. So again, if you have the ability to print out or to cut apart some, note cards or something like that, this will be a problem that you can do in that fashion. So what you would do is you would take those little pieces and you'd piece them all together in a rectangle. Okay, so you're trying to make the rectangle. And once you make the rectangle out of all the pieces, you again count along the top and you count along the side, just like you would have done in 8 and 9. And you would say what that equation was. This value on the top times this value on the side equals the combined expression in the middle. And then if you do it 2 different ways, because there's actually 2 ways you can do it, can get the same, not the same arrangement, but it'll be the same tiles in the middle. The arrangement will look different, and it will give you a different algebra expression for the multiplication along the top and along the side. All right, so now you're set to do activity 5.4. Once you're done with these, of course, come to join me with Zoom when we take a look at Algebra Tiles that day, or send me an email if you're concerned or have questions. Thanks so much.